Hey everyone, so last lesson of Unit 4, we're going to talk about isosceles and equilateral triangles. And we've already defined these when we classified triangles in Lesson 1, um, but we didn't really solve many problems involving them. So using their specific properties to set up equations and then find values. Um, so looking at the base angles theorem, um, finding missing angles in triangles, and how to use an isosceles to solve a problem. All right, so this is an isosceles triangle. An isosceles triangle has two parts in terms of the legs and then two parts in terms of its angles. So the legs are the two congruent sides. So this is a leg, and this is a leg. No matter how you rotate it, if they are um, congruent, if you have two congruent sides, then it's isosceles, and those two sides are the legs. So AB is congruent to AC. So those are the legs. Sorry. All right. The other side is what we call the base of the triangle, and that's whether it's sitting on it or if we turn this whole thing upside down, it would still be the base. It's the non-congruent side, right? The one without a tick mark. So in this specific triangle, it's BC. All right, so looking now at the angles, we have two types of angles. You have the vertex angle, which is where the two congruent sides, or the legs, where they meet. So the angle that the legs make together, this angle right here, is your vertex angle. We'll just color code that there green. Okay. And then your base angles are the other two. So the two angles that touch the base side. Right, so they're touching the base right here. This one's touching the base right here. So yes, they touch a leg as well, but they're the only two angles that are touching the base. So in here, you can see we have angle B and angle C are our base angles. You have two legs, one vertex angle, one base, but two base angles. So keeping those all straight will be the key to setting up some of these problems. So your base angles theorem states if two sides of a triangle are congruent, so essentially if it is an isosceles triangle, then the angles opposite them are also congruent. Opposite in any polygon that we talk about means across from. So this side here is opposite to this angle here. Right? This side here is opposite to this angle here. Well, if this side and this side are the same, then that means that angle B and angle C are also the same. So your base angles are congruent. So if it has isosceles, all right, the base angles are congruent. That's another way to put that. Okay. All right, the converse of that is also true. So remember, in a converse, we switch the if and then. So go ahead and pause the video and try writing the converse statement for this. Okay, so if two angles of a triangle are congruent, then the sides opposite them are congruent. So we just go in the reverse order here. If you see B is marked congruent to C, then those opposite sides are also congruent. So angle B is congruent to angle C, then we can conclude that AB is congruent to AC, okay, which are the legs, if you look at the label, of the triangle. So if the base angles are congruent, the legs are congruent, is another way to state that theorem. All right, so putting all that together um, to find missing angles or missing sides in a triangle. So here we have a isosceles triangle because we have two sides congruent, and we're given the vertex angle. All right. So the measure of angle A is 40 degrees. We know that, oh, sorry, I'm looking at the wrong. The measure of angle A is 50 degrees. All right, and we know that angle B and angle C are the same measure. Okay, so we know the measure of angle B plus the measure of angle C plus 50, or the measure of angle A, is 180. Okay. Well, these are equal, so you can replace that with an x or a y, or you can just say 2 times the measure of angle B is, take away 50 here, 130. So that means the measure of angle B is 65 degrees, which automatically infers then that the measure of angle C is also 65 degrees. Okay, you can double check yourself, add those three angles up, and see if they add to 180. Okay, another way to do it, just kind of mentally, know that you're subtracting the vertex angle from 180 and then dividing it by 2. Okay. When algebra is involved, though, it's not that simple, not as simple. We see that this base angle is x, so then this base angle needs to be x. So we can set up our equation and say 3x plus x equals 180, all three angles together. Right, so we have 5x is 180 and x equals 36. Right, so the measure of angle B, answering my question up here, is 36 degrees, and the measure of angle C, because it's also a base angle, will once again be 36 degrees. Okay, so I'm going to have you try this one on your own. Find the measure of angle A and the measure of angle B. Mark your given information so that you know which sides are the legs and which side is the base. Okay, for this one, we're going to do it a little bit differently. We're not setting these equal to 180 because we know nothing about the angles. All right, we do, though, know that this angle and this angle are congruent, which by our converse base angles theorem states that these two sides are congruent. Well, if you have two congruent sides, you can set their measures equal to each other. That means they are the same. So when we solve this here, by minus 3x and minus 12, we get x equals 3. Okay, it says find the value of x, so I've answered my question. Right? Okay, this one is a little bit different because it is now an equilateral triangle. So some of you will quickly learn what the measure in every equilateral triangle is, but let's look at it first. Because these two are the same, all right, then these are the same. So this is also 2x. Okay. But now these two are the same. If this is 2x, then this one is also 2x. And so we have 2x plus 2x plus 2x is equal to 180. So 6x is 180 and x is 30. Well, if x is 30, and this question doesn't ask this, but just something to think about, then this angle measure is 60 degrees, as are the other two. And you think about 60 divided evenly between 3, or multiplied by 3 is 180. So every time you have an equilateral triangle, this angle automatically, you can just set it equal to 60 and solve. All right, so your base angles theorem um, and your corollary converse of the base angles theorem are the last two things I'm going to fill in here. Okay, so it pretty much uses what I was just talking about, the fact that up here it was equilateral, so we knew that all these angles were the same. If a triangle is equilateral, then it is also equiangular. So when I see all these tick marks, I can automatically go in and fill in our congruency marks for the angles. All right, and then the converse of that is also true. If a triangle is equiangular, then it is equilateral. So if you see all of the angles marked, you can automatically state that AB is congruent to AC is congruent to BC. All right. So those are even a little bit simpler to solve because you can pick any two sides and set them equal, any two angles and set them equal, or set an angle equal to 60, depending on what you're trying to do with that problem. All right, and that's it. Have a good night.